Hey there, Pre-Calc. We are working with sine and cosine function now. So we have to know what in the world it looks like. But before we even start to do that, I just want to point out one part here. Okay, so we've dealt with a lot of different parent functions. So absolute value, quadratic, any of those would do. Right. So keep in mind if we had maybe 2 times x minus 5 squared and then plus 1. So those represent a couple different things here. So we have A out in the beginning. Right now my B is 1 because we didn't do any horizontal things to this just yet. And then we have, I'm sorry, horizontal stretch or compression. The next item we have is C, right? And this is what moves us left and right. And then of course D on the end. This is what moves us up and down. Okay, so we have vertical stretch and compression out of that first one, horizontal stretch and compression out of the second one. We have movement left and right. Remember, this one's opposite in the inside, and then up and down. Okay, so that's kind of what's going on here. That A value, vertical shrink, horizontal stretch, shrink. Remember, anything inside, these items are always backwards. So just like when we move it left and right, it's also going to be the same thing for your horizontal stretch and shrink. So we have a couple different things happening here since we have a couple items going on inside those parentheses with B and C. So we kind of combine those to get that horizontal translation. And we'll see that all in just a minute. What I'm going to do is try and take you over here and show you what happens. What we're going to do is we're going to think of a tire, like a bike tire. And we're going to do is we're going to track the points from the beginning, okay, starting at 0, 0. And we'll talk about this more in class. But I just wanted to watch this part of it to kind of see why we have the curve that we have and what's happening. Okay, so you can see what's happening is it's going to reach that maximum of 1, and then it's going to come back down, and it's going to go back through. And it has to reach that minimum of -1 because we're talking about the unit circle here. But notice the red circle hasn't been completed just yet until we get back to that point D, and then we finally make it. Okay, so that's what's called when we start from one point and we get back to our beginning point, right? We want to find out how long that takes. Well, that takes 360 degrees, right, according to the circle. But the next part of it is, so when does it meet back to the x-axis? Well, that's when we met back at, let's say, half of that circle, so at pi. Okay, so what I can do is I can then assume back in the middle that this is half pi right here is when we're going to reach that maximum. So when I get here, this is going to be 1.5 pi or 3 pi over 2 until I get to 2 pi here. So we're going to do, as we work on things today, we're going to try and break it into those 4 points to figure out what those 4 points should be and how we move those around. So that's our sine function because these are our x values. And think of, remember, this is 1, 0. So that's where we're going to start off at 0. And if I asked for the cosine function is 1, right? So that's the one that's going to start up top here, and then it's going to come down and reach its minimum, come back up, and then we'll get that opposite of that that curve, if you will. All right, so let's get back into OneNote. I do have that linked in your notebook. I think it's kind of a neat thing to watch. It's mesmerizing in some fashion. So a couple things we started to talk about. Okay, so as we deal with that sine or cosine function, we have that A value. Before it gives us like a stretch and things that are going on. And what it gives us now is it tells us about the height of the curve or its amplitude. Okay, so that tells us, all right, instead of a unit circle going up to 1, then it's going to go up to maybe 2 or 3 or whatever the number is. So that tells us what we have to do with it. And that one's going to be pretty straightforward. That one I don't think is going to be too confusing as we work on this today. The next thing is we have the B term. Okay. So the B term is going to tell you your period. The period is how long it takes to complete one cycle. Okay, so that means from down to up until I get back here. So we have the beginning point to the ending point, right? That's called one period there. How do I find that? We're going to take 360 divided by b if it's in degrees. Or I take 2 pi, right? 360, 2 pi, same thing, divided by b if it's in radian. Okay, and we can also reflect as we get some negatives and flip them around. All right, the c. All right, that's your phase shift. Okay, so this is left and right, left and right. So how far should I go left and right? And here's how it works. Remember, that was the number inside the parentheses or inside the absolute value, so it's opposite. So notice we have an opposite on here, but it is combined with B. So we're going to use that in combination. All right, and D, this one is going to be one of the easier ones, just like A. That just tells us how much to move the entire curve up and down as we work it. Okay, move the entire curve up and down. So that's going to affect the range as we look at these. All right, so what we're going to do is pull these things out. We're going to work with them as we go. So we want to identify A, B, C, and D. I'll be honest, sometimes they interchange lowercase and uppercase. It really doesn't matter at this point. We just want to make sure we can identify those numbers. And we want to graph at least one full period, and so that you have a way to check, right? So we're going to work with some of these, and I want to make sure whatever tool you're using, I want to make sure you have straightened out. Now, if we're going to graph it on the graphing calculator, this one, I changed the window. I think we're 0 to 2 pi. Yeah, I said 2 pi, 0 to 2 pi on your x-axis. On your y-axis, I think it made it like -5 to +5 to give me a nice viewing window. Now that's going to be pretty good. It gives me the 2 pi area. So if your period is longer than that or shorter than that, just keep that in mind. And it threw a bunch of different graphs in here. Now, if I said 2 pi, that means over in mode, what should I probably have? All right, and that's going to be in radians right there. Remember, that's where we change it back and forth. So just remember that your calculator is in radians if you're going to use this as we work through some of those graphs, right? So I had a y equals going on here. So those were just some different graphs that I had in. All right, so let me shrink that out of the way. Now I know some of you are like, yeah, that's great and all, but I don't really like to use that. Okay, so here's what we have. In Desmos, there's a little wrench over here, and it should be defaulted to be in radians. Okay, if it's not, go ahead and click that over in radians. And then what you see is here's that sine function we were dealing with, we were taking a look at. And look, it goes over and over and over again. I can zoom in. And the nice thing is, since I'm in radians, you're like, oh, okay, check that out. So that's that pi over 2. This is your pi. And then 3 over 2 pi. And then finally 2 pi. Notice we're back to where we begin. So that's called 1 period of what we're dealing with. Okay. Now, we also said that the cosine, right, it doesn't start at 0, 0. Where does cosine start? Okay, because the cosine values. So what I'm really looking for are the beginning, the end, right? So we have these 4 major marks is what we're looking for in every single graph. Okay, but that is just the basis of what we're dealing with so far. Okay, so first idea that I have is the sine function. Okay, so does that start? Where does that start? That's the one that starts at the origin, right? So the next thing I want to do is find out 1, 2, 3, 4. Now you want to get pretty good at marking these out as best you can, because we want those 4 marks, really 5. So the A value is -3, the B value, right? So that's a 1. The C value, we didn't add anything onto it, so it's 0, and the D value is 0. Right, so this one, we don't really have to get into too many of the other things, but what I'll notice is since it's a sine function, my domain is going to be all real numbers. -3, so that means our sine function normally looks like, and here's, I want to try and get these pretty close to what they would have been. Okay, so I'm going to mark this as 1 and -1. Now I'm using these in highlighter because this is just the basic sine function. Right? This would be the parent. So we're going to work through like this. Right, so they shouldn't look like semicircles. They're going to kind of keep working through those. But here's a couple things that have to happen. We have to flip it over, and I have to make it taller. So 1, 2, 3, and 2, 3, -3, +3. And still going to have the same starting point because it's just a multiplier. So my range is going to go from -3 to 3, and it's going to hit those points. So that's a good thing. So the amplitude, that A value is 3. Now the negative, all that did is that's going to flip it over. We're going to see that in just a second. And then the period, we didn't change any of that because our B's and C's and D's, they were B's and C's were 0. So it's actually 2 pi over top of 1, which is the B value. So it's just 2 pi. So that seems a little bit silly to write it, but I want to get into good practice. All right, so since it's upside down, that means I have to hit 3 at this point. I'm going to end up back at the x-axis. I'm going to hit 3 at this point and end up back at the x-axis. So I want to try and draw it as much of a true curve as I can. I'm not trying to draw circles. So that's what our graph is going to look like. We want the hot pink one here. All right, and I'm going to start with the parent to get that started with. Okay, so that's our first one. Not too shabby. All right, cosine. So we have a couple of reminders. What's cosine look like? So here's our original cosine. Right? It starts here. Okay, so it's the one that does not. Okay, I like to remember it because cosine has a 0, and things are kind of weird with this. So that means it doesn't go through the original 0 or the origin. So there's a couple different ways to deal with it. Okay, that's how I remember it. So if that helps, great. If it doesn't, come up with one. Okay, so A is 1, right? So A is 1 in front of here. B is 1. C does not exist, right? Because that would be inside parentheses, but now D is 1. All right, so the domain, we saw that in the other graph. That's all real numbers. I did not change the amplitude, right? Because the amplitude is 1, so that means the highest it's going to get is 1, and the lowest it's going to get is -1. So -1 to 1. And the period, 2 pi divided by 1 is still 2 pi, which means I want 1, 2, 3, 4. So this is 2 pi. This would be pi. All right, so what happens with our cosine originally is I would have, so I'm going to use highlighter again. I would have here, and here, here, and here, and back to here, right? So this is, ooh, that one's a little rough, but that's our original. But we have one little change here, right? This +1. So what I'm going to do is take all these points and move them up 1. Okay. So that means I wrote my domain in a little bit too early, or my range in a little bit too early, didn't I? Okay, so the original would have been 1 to 1 because the amplitude didn't change, but we had a vertical shift. Okay, so now we're going to go from 0 to 2, always starting with the least to go into the greatest. Okay, so some of you may have already caught that before. All right, so cosine x and then +1, right? So we can always check these out. So if you try some of these, you know, without any of the video, we can kind of look at those. Okay, 2 pi gets us back to 2, right? So now I have kind of this midline here, and the old x-axis is now x or y equals 1. So that's kind of the transition that we're making as we work on these today. All right, next one. All right, so what do we got? We're always filling with what we have. A equals 1, B equals 3, C equals 0, and D is also 0. All right, so amplitude is 1, right, and it's not going to get pushed around too much. The domain is all real numbers. So I might start again by saying the sine function. Right, so we get our 4 marks on here. 1, 2, 3, 4. And again, it looks better the more accurate we can make them. Let's see, what else? So normal sine function would go 1, -1. So we're always trying to get kind of 4 points. 5 if you count the beginning and the end here. Okay, so that's our normal sine function, but now we have something different here, right? We have a 3. So what we have is 2 pi over 3 for the period, right? Because it's going to be 2 pi over the b value. That's how we got that. And what that does is that tells me that this entire graph is actually going to be only 2 pi over 3 long. Okay, so where's the middle going to be? Well, 2/3 should be 1/3 should be the middle of it. So if I just alter the scale, I can actually draw the exact same graph because we're not changing the range or anything else. So for our purposes, we get to kind of cheat and just change the scale. So the range is still going to be -1 to 1 because we didn't change any of that. But I want to show you over in Desmos what that difference looks like. Okay, so we had sine of x, okay. And let's plop this one on here, and let's do sine of 3x. So here's what's really talking about is the red one is the original, and notice how when we do 3x, we've changed the period. We've made it 2/3. Instead of going the whole way out to 2 pi, we're going to 2/3. So notice how squished it is. And that's what happened, remember, when we multiplied by 3 in here. We made a horizontal instead of a stretch, made a compression. So it shortened the whole thing up. So our strategy to do that is give those 4 marks. We're going to find out what that period is, and then we're going to make that happen and then find the middle of that for the middle of our mark. So our graph is a little bit easier, so I don't have to really compare it to the original graph as much. All right, so let's take a look at one more. So we have the sine graph. Let me get this thing out of the way here. There we go. Look at the sine graph. And, if you don't want to deal with the 90 degrees, remember, what is 90? Well, that means we're talking about pi over 2. Okay, so that means we're going to move to the right pi over 2. So we'll show you how we're going to deal with that. So right now, a equals 1, b equals 1, c equals negative pi over 2, and d, there's nothing added or subtracted after it, so that's 0 again. So domain, all real numbers. Kind of silly that we keep putting that on there, but it is what it is. The amplitude is 1, so I know I can mark 1 and -1. The next thing we have is the range is going to be -1 to 1 since we didn't make any of those changes. So I got 2 pi over 1, which is just 2 pi. So that means I'm going to mark my 4 marks, 2 pi, here's pi. All right, so we could say half pi, and we could say that we're going to deal with 3/2 pi here over 2. And we're totally going to need those this time, right? Because we're talking about the sine function. So I would start here, 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 and here. So I'm going to go with the original one in highlighter. And then what we'll do is we'll come back with what's going to happen. So what had to happen here? The phase shift, right? So if it says negative pi over 2, that means we have to move to the right pi over 2. So I'm going to take all these points and I'm going to move them over one more phase. So that means I got to mark the next one. Like, geez, Louise, I got to keep marking these. Remember 2 pi, because that was 3 over 2. This is 4 over 2. So this is 5 over 2. And now what we'll be able to do is connect these to get our sine graph. But except for this time, we pushed it all to the right 90 degrees or pi over 2. Domain doesn't change, range doesn't change, right? So we're going to get one period to get through those.